So consider a zero coupon bond with $100 face value. Again, that's usually a round number like 100 or 1,000, or it can be more, 5,000, 10,000. Here it's $100. Each bond has a face value of 100. So now you know what that means. That means at maturity, in this case in 1.5 years, that issuer, the borrower, will pay each bondholder that has the bond at that time when it matures. They still hold it, haven't sold it, or they've bought it in the aftermarket, but they hold it when the maturity arrives. Every one of them will get $100. Every bond will get $100 paid to it. So what is the value of this bond? So we are trying to figure out the price. How much is this thing worth? If its yield to maturity is 4.5%. So what's going on here behind the scenes is you have done your analysis and you've decided that your required return from investing in something like this on an annualized basis is about 4.5%. Again, that's a matter of what else you could do with your money and how risky this issuer and this particular bond is. But you've decided 4.5%, or the market collectively has decided 4.5% would be a fair compensation for investing in this for 1.5 years. Okay, so then what price does this imply? What price would give us that 4.5 annual return? So that's given by our formula, equation 3.4. Price is that face value discounted at that return, 4.5% required return, right? So we plug in numbers, and that gives us the fair value of this bond. If we were to pay $93.61 for this bond today, hold it for 1.5 years, and as we hoped, the issuer is able to pay $100 for each bond, then we would have earned an annual return of 4.5%. Okay, now this is yield to maturity, so our expected return, if you hold it until maturity, in the best case scenario, if this pays, right? If this issuer is a risky like a corporation, and if they go bust between today and that 1.5 year, and if they are not able to make that $100 face value payment, either they pay zero, they are not able to pay anything, or partial default. In that case, our return will be less, right? So the best case scenario, if the issuer is able to make the payments, then our annualized return from this will be the yield to maturity, which is 4.5%. And that's the price it implies. We will want to pay at most $93.61 if we want to earn 4.5% on this investment. Right, let's move on. Example 6. This is an actual, let's use some actual data. Actual bonds issued. As I had said, the Treasury, US Treasury is very, very active in the bond market, especially zero coupon bond market, by issuing Treasury bills all the time. Very, very common. There are different maturities, but there are always zero coupon bonds, Treasury bills, and always maturities of 1 year or less. So if you follow this link and go to the Treasury website, which we will do a lot of this, let me show you some auction results and the different Treasury bills that they have issued over the last several weeks. Most recently, they've issued some 4-week and 8-week Treasury bills. But the one I want to show you is this 52 weeks. So this is 1 year, right? There is a CUSIP number, which is a special ID for each of these bonds that are issued. And this tells us here the investment rate that it says for that 52-week Treasury bill is that the market clearing yield that investors bid for. So there was an auction held, and they were able to, US Treasury targeted to borrow $34 billion with these 1 year Treasury bills. And investors bid by saying what is the yield they are willing to accept. Some of them were as low as 0.09%. Some issuers, investors bid 0.1%. But they were able to fill up the whole thing. Their target $34 billion of borrowing at a 0.142 yield. So let's go back and say, okay, if the yield that they decided on this issue that applies to all the borrowers or all the buyers of this bond is the Treasury is going to issue this at yield to maturity of 0.142. At what price are they selling this time, right? So this yield to maturity implies a price. So let's see. If you go back, We know the formula we need to use, equation 3.4, right? The price of the bond is the face value, which is 100, discounted at that yield to maturity, raised, so 1 plus yield to maturity raised to n. Here, yield to maturity we learn is 0.142. By the way, it's really, really, really low. Why is it so low? It's because we are going through a historically low interest rate environment. We're going to talk a whole lot more about this later on. Interest rates are very, very important for us in this part of the course. And on top of that, this is the US Treasury we are talking about. So this is not like a risky corporation. Why? Because US Treasury is not risky because they can print dollars, right? So technically, the US Treasury cannot default. Now, there are political reasons. Sometimes there's talk of Treasury defaulting. Sometimes you may hear about that. But technically, as long as there's political will, US Treasury cannot default. They will never run out of money. If you borrow at your own currency that you can print, you cannot default. So that makes the risk of these things very, very low. But on top of that, we are going through a historically low interest rate environment. So the US Treasury is able to borrow at very, very, very cheap rates, 0.142% for 1 year. So what does this imply for the price of the zero coupon bond? Let's just plug it in the values, right? 100 divided by 1 plus, now remember, percent, 0.142 divided by 100, that's 0.00142. We are working with really tiny numbers, so be careful. That gives us a price approximately of $99.86. So that's the price at which the US Treasury would sell these to investors, or sold a few days ago, all right? So if I'm a bondholder and if I bid, let's say 100 of these, I would give this much for each bond, say times 100. So I give this much, and then in 1 year, US Treasury will give me 100, right? So I'm buying these at a discount, but a tiny, tiny discount. That difference, 14 cents per $100 face value, that corresponds to 0.142% return over a year. And let's confirm that number. If you go back to the Treasury website, and if you click on that link, it's going to show us here at the end that indeed price per $100 of face value was 99.858 and on. So essentially 99.86, and which is what we found, right? So that's the price. That's how much they borrow from bondholders. This is how much bondholders pay, and then Treasury will pay them $100 in 1 year, because this is a 52-week Treasury bill, zero coupon bond with 1 year maturity. Let's do another example. This time, let's assume we are looking at the secondary market, where these bonds that were first issued a while back are now trading. So investors are buying and selling this from each other without the issuer's involvement at all. So then we can observe the price, and then the question is, what yield to maturity does that price imply? So example 7 is zero coupon bond with a 4-year maturity, so 4 years remaining, to receive that face value of $1,000 this time. That will be paid directly by the issuer to whomever is holding that bond at that time, is now trading at $822. So again, a discount, right? What is this bond's yield to maturity based on this price? So what yield to maturity does this price of $822 imply? So the solution given by equation 3.5, yield to maturity is the ratio of the face value to the price of the bond raised to 1 over n minus 1. If you populate this formula, we have 1,000 divided by 822 raised to 1 over 4 years, so 1 over 4 minus 1 is roughly a number like 0.05022. And then if you convert this decimal to percentage by multiplying by 100 and round to 2 decimal places, we end up with a yield to maturity of 5.02%. So you look at this and say, all right, if I buy this zero coupon bond at this price, hold it for 4 years, and assuming that the issuer is able to make the $1,000 payment, then I will have earned just a little bit above 5% per year. Then you decide, is this worth it? Is this good enough? Will this compensate me enough for time value of money, opportunity cost, the riskiness and then you decide. If you would need a higher yield than this, then you'll decide, no, it's not worth it. This bond is worth less than 822 to me, so I'm not gonna buy it. If you would be fine with, say, 4.5% yield based on all the other considerations, then you'll say, you know what, 5 looks pretty good. And that implies you value this at more than 822. So you'll be more than happy to buy this at this price because your required return is less than what the market is implying, the yield to maturity implied by the market price right now. Okay, so that's the calculation you are doing. So this also reveals an important thing about the relationship between yield and price. This is very important. We're going to talk more about this later on, but let's mention it now. There's a very important inverse relationship between bond yields and prices, right? So if the bond yield goes up, so let's say your required return from holding a bond goes up. Why? Maybe interest rates in the economy are going up. Maybe that bond is riskier all of a sudden. So you need higher returns. The only way you can get higher returns, since the cash flows are fixed, they are set, right? The only way you can get more return is if the price goes down, right? So there's a mathematical and conceptual negative relationship between bond yields and prices. Yields go up, prices have to come down. If yields decline, so our required return is declining, we are going to be willing to pay more for it, so the price implied by that yield will go down. Let's do one more example. Example 8. Remember that AT&T zero coupon bond we looked at before? That really exists. So that's 0% coupon, zero coupon. And if we go back to that page, we can see it's reported that about a week ago, it traded in the secondary market. So some investors bought it from other investors. And it traded at 98.66, right? And face value is 100. And now there is a little over 2 years left. So we can figure out if we were to buy this at this price, right? So if it was us that bought it, let's say a week ago at 98.66, and we hold it until maturity, November 2022, and then collect $100 per face value from AT&T, what would be our yield to maturity, right? So let's go back. We know our formula is equation 3.5. This is how we compute it, right? Let's plug it in the numbers. One thing we got to do is, so we have a little over 2 years left. So what is our n in that formula, right? N is the number of years. So roughly saying we have 26.5 months from mid-September to sort of the end of November 2022, say 26 and a half months, divided by 12, that gives us roughly 2.21 years until maturity. So that's going to be our n. So let's plug that in, and we're going to have yield to maturity 100 divided by the price we are observing now, 98.66, raised to 1 over 2.21 minus 1. And we can actually do this in the calculator really quickly, right? So what we are doing is 100 divided by 98.66, 1.013582, raised to, so what I'm going to do is I'm going to write 2.21, but before I press equal, I'm going to take the reciprocal, so 1 over this, right, which is 0.452489. Then I press equal, and that gives me minus 1, 0.006123. Convert that to percent by multiplying by 100, and we have roughly 61%. So that would be our yield to maturity. So compare that to the US Treasury these days, able to borrow at 0.14% for 1 year. AT&T is able to borrow at 0.61% per year for a little over 2 years, right? So AT&T has to pay a premium, right? Or in other words, AT&T bondholders demand a premium for buying AT&T's bonds, which have some possibility of defaulting within the next 2 years, a little over 2 years, compared to the yield they demand when they are lending to the US Treasury.